And so first of all, we need to define what a radical expression is. A radical expression contains a radical, otherwise known as a square root. So when I see a radical expression, this is what it means. Something like that, that little square root sign. We call that square root sign a radical. Okay? And the radicand is the expression inside the square root. So if I've got a square root here, what is the radicand? 4. The radicand is this one right here. Okay? Now, is it important you know those? A little bit, but are you going to be tested on it? No. But when I talk about things and I talk about the radicand and the radical, that's important to understand, you know, that you need to know what those are. So a radicand is in simplest form if the radicand only has a perfect square factor of 1. This first one isn't going to make a whole lot of sense right now. Okay, but it will after we look at some examples. The radicand doesn't contain a fraction. So you can't have a fraction, you can't have something like this. Square root of 1/4. Can't do that. That's bad, taboo. Okay, bad. No square roots are in the denominator of a fraction. So in other words, I couldn't do this. That's bad. Okay, now these rules follow you through all the way to your senior year with me. Okay, you can't have a fraction underneath a square root. You can't have a square root in the denominator. So keep that in mind. So today we're going to simplify. And in order to simplify, we're going to make factor trees. So if you want to go ahead and write down root 80, square root 80, that's how it says. Now what I'm going to do is I'm going to break that down. Now all I need are any two numbers that multiply to give me 80.
20, 40.
20 and what?
4.
4 and 20 would work. I could also do 8 and 10. I could do any two numbers. And you don't have to do the same as somebody else. I could do 2 and 40. Okay, so you don't have to do the same exact thing. Now, I'm going to break 4 down. Can I break 4 down? 2 and 2. Can I break 20 down? Yep. Any two numbers that multiply to give me 20. So I could do 4 and 5. I could do 2 and 10. It doesn't matter. Okay, now, can I break 2 down? It's 1 and 2, right? So anytime it's 1 in the number itself, you're done. So I'm done with the 2. I'm done with this 2. What about 4? 2 and 2. What about 5? I'm done because it's only 1 and 5. So whenever a 1 is one of the factors, you stop. So now, can I break these 2's down? No, so now I'm going to look at what's the bottom of every branch. Here's a 2, here's a 2, here's a 2, here's a 2, and here's a 5. Those are the only numbers I'm concerned with now. Okay? To simplify a square root, I'm looking to take things out as pairs. So you can only take one out if it's got a pair. So do I have a pair of 2's?
Yes.
Yep. So you know what I'm going to do? I'm going to take one of the pair out. Okay? And these are gone now. Whenever you circle them, they're gone. Do I have any other pairs? I have another pair of 2's. So I'm going to take that 2 out. Do I have any other pairs? No. So then what I'm going to go ahead and do is write my square root sign and whatever is left on the inside. What's left on the inside? 5. So now my final answer, I'm going to take 2 times 2, which is 4 root 5. And that is what root 80 simplifies to be. Now real quick, when I take a pair out, I only take one of the pair. Okay? So let's break this one down, 54. Any two numbers that multiply to 54?
7.
9 and 6. I could do 27 and 2, just as long as they both multiply to 54. Can I break 9 down?
3 and 3.
3 and 3. What about 6? 2 and 3. Can I break any of those down? No, because those are all, if you would break them down, they would be 1 and 3, 1 and 3. So these are what we're looking at. Any pairs?
Yes.
I have a pair of 3's. So how many do I take out?
1.
1. Do I have any other pairs?
No.
No. So whatever is left stays on the inside. So I have a 2 and a 3. What do you do with the 2 and the 3? Multiply them, so my answer is 3 root 6. Good. Okay? 3 root 6. Questions? Oh, skip it. Let's go back to that one. I want you to try this one for me. Let's see how you do. Okay, square root of 180. Any two numbers.
Figure it out yourself.
Okay, so remember, just because somebody did 2 numbers for 180 doesn't mean you have to do the same 2. I will tell you that the bigger numbers you start with, the shorter your tree is going to be. So if you do 2 and something with the 180, your tree is going to be long. But if you pick 2 bigger numbers at the start, it's going to be shorter. Somebody got theirs that they want to review? No, I don't. I want you to write yours down, please. You can take up your paper.
Never show your fear.
Okay, you take here. I'll give you pink. So go ahead and write it down with pink, please. Yes, it is.
What's on the special?
Okay, nice job, by the way, 6 root 5. Now, I noticed somebody else did something different. Okay, would you go write yours up? All right, we're going to see another one. Okay. All right, go ahead and write yours, Nick. Is that a 3? Okay, there we go. Now something different. Now if you noticed here, okay, Nick had 3 rows, so did Maddie. If you did the 2 and the 90, you probably had a little bit more for your rows. Okay, another one you could have done the 2 and the 90, which is what some of you did. You could also do 10 and 18. Okay? 10 and 18 would be 2 and 5. 18 would be 2 and 9, and then 3 and 3. Now, one of the questions I think some of you had is that if they're separated, as right here, notice my 2's are apart, are those still considered a pair? And the answer is yes. So if I see 2 2's, that's a pair. They don't have to be right next to each other to be taken out. So I would take out my 2 there. Here's a pair of 3's. I would take my 3 out here. 5's the lone one left inside the square root, and you get your answer 6 root 5. Any questions over that? Okay, pretty straightforward. Okay, let's look at this one. Now the plan is that we're going to probably break this section over 2 days just because it's so important that you're able to simplify square roots. Okay, it's something that will follow you through all the way through your senior year. So what do you think I'm going to do on this one?
Simplify.
You're going to simplify this and then multiply it.
You know what I'm going to do?
Square roots.
That works too.
Okay, now some people say, hey, let's multiply 14 by 2 and get 28. Well, then you're back to square one where you're having to break 28 down. So it's better just to do it this way. And then what I do is I say, oh, can I break 14 down?
Yeah.
What will that be? 7 and 2. Can you break 2 down? No. So here are the ones I'm looking at right here. Those 3 numbers is it. Looking for pairs. Do you see a pair?
Yes.
The 2's. So what will your final answer be? 2 square root of 7. Nice job.
This is like what it does in your calculator.
Yep. And your calculator does in fact do these. This is the thing. I'm going to make sure and check your work to make sure it matches. Okay, so don't just think you're going to type it in and go from there. All right, what I want you to do is write this down right now, and this is where we're going to pick up tomorrow. Okay, so tomorrow we're going to pick up with this slide, and we're going to talk about how you take the square roots of variables. So not just numbers, but letters. So when taking the square roots of variables, if you take an even power from an even-powered variable and you get an odd, you must use the absolute value sign. Now, that's not going to make a lot of sense right now, but that's where we're starting tomorrow. Even, odd means you're going to use absolute value. So even, odd. What? Oh, that sounds in it. Okay, what I'm going to go ahead and do right now is I'm going to go ahead and go to the assignment page. If you're still writing, don't worry about that. When I'm done, I will come back into the slide and you can write it down then. But your assignment then, since I know some of you are kind of sitting there, your assignment is on page 631, 17 through 34. Now, you will not be able to do all of these tonight. Okay, so this is a two-parter. So I want you to do as many as you can. When you get to the variables, you need to stop. Okay, so we will continue with this tomorrow.